This video is all about the trapezium. I'm going to start with this trapezium. I'm going to then move on to the isosceles trapezium. It's a four-sided shape, 1, 2, 3, 4 sides, but it's actually one of the hardest ones to identify. And the reason it's so difficult to identify is that it can take many forms. These are all also trapeziums. Trapezia, I should say. Trapezia is the plural of trapezium. Not trapeziums, trapezia. Okay, these are all types of trapezia, but they look completely different. How can that be? Well, the reason is that the trapezium only has one property, and because it only has one property, it can take all sorts of different looking shapes. The one property that it has to have, though, is that it has one pair of parallel sides, which I've identified here with the arrows. The left and the right and the left are parallel to each other. That makes a pair. The top and the bottom, well, they're not parallel, so we still only have one pair. What about here? Well, here there's only a pair. Here there's only a pair. Here there's only a pair. And here there's only a pair. Let's look at a whole range of different possible trapezia. Here's a rectangle, 4 sides, but I'll change it just a little bit. I've now only got one pair of parallel sides, so it's a trapezium. That's still a trapezium. That's a triangle. That's a trapezium, because it's just got one pair of parallel sides. I know this one's quite small, but it's parallel to the bottom, and it's only one pair. What about if I move this over to here like that? Yep, still a trapezium. What about there? Yep, still a trapezium. It's only got one pair. The left and the right, they're not parallel. What about here? Yep, that's one pair of parallel sides. What about here? Ah, now there we have two pairs. We've got the top and the bottom parallel and the left and the right parallel. So that's actually a parallelogram. What else could I do? I could go big. This is not a parallelogram. This is not a trapezium either. In fact, it's got no parallel sides. It's got no sides of equal length. That is just an irregular quadrilateral. Let's see if I can make another trapezium. Oh yeah, there's one. Can you see the pair of parallel sides? What about if I move that to there? Yep, there's another one. Oh, the parallel sides have switched though. It's now left and right. There? Yep. There? No. That's a rectangle and it has two pairs. What about here? Oh yeah, look. One pair of parallel sides. Can you see just how many different ways a trapezium can look? Is that a trapezium? Of course it is. Is that a trapezium? Absolutely. Is that... Come here. Is that a trapezium? Yes. What about this? No. That's irregular. What about... Come here, you. Okay, back to a triangle. Loves triangles. What about that? Yep, only one pair. Bring this one in. Come here, you. There, like that. Yep, that's a trapezium. In fact, that's a special kind of trapezium. That is an isosceles trapezium. Can you see why? What about if I made it an isosceles triangle? That's an isosceles triangle because it has a pair of equal sides. I can make it an isosceles trapezium by giving it a pair of equal sides. And that brings me onto the isosceles trapezium. The isosceles trapezium obviously has a pair of parallel sides. We know that. There it is. But it also has a pair of equal sides. So it's got one pair of parallel sides and one pair of equal sides. And one of the ways to spot it is if you imagine the equal sides carrying on. Okay, they're going to go off the page. But it would create an isosceles triangle. Okay, So the trapezium, difficult to spot. It only has one really important property. That's the fact that it has to have a pair of parallel sides. It then becomes an isosceles trapezium if it also has one pair of equal sides. What would happen if it had two pairs of equal sides and only one pair of parallel sides? I'll let you figure that one out. Doesn't sound possible to me. That's the end of the video. Thanks very much for watching. Bye.